So we're making a box. The box has a square top and bottom.
Quick question, do you think 3 was online?
I believe it is.
Is number 1?
I don't know. I'm not entirely sure. So since we have a square top and bottom, we call both of those X or whatever. We'll call this one H. Okay. So we want to minimize cost, and we know it has to hold 2,000 cubic meters. Let's walk through it. We've got cost. We got to talk about cost, okay? Anytime they talk about cost, Judy Kim, and they tell you how much something costs per meter or per square meter or anything, we're going to take, Judy, we're going to take the total area in this case and multiply it by the cost. So when it says the top and the bottom cost $2.50 per square meter, how many square meters do we need for the top and bottom total? 5. No, we need 2x squared, really. Yo. Shh. The area for top and bottom is really 2x squared. There's 2 of them. And we are going to multiply that by $2.50. So it is 5x squared. So the cost for the top and the bottom is 5x squared. Okay? The cost for the sides, which all have an area of xh, but there's 4 of them, they cost 50 cents per square meter. So we multiply 0.5 times 4xh, and that gives us 2xh.
Wait, are you multiplying 2x squared by 5?
I'm multiplying 2x squared by $2.50. Okay? So that's our cost equation. Now we need to derive it, but we got to get rid of h first. Okay? So we use the fact that the volume has to be 2,000. So 2,000 has to equal x squared h, which means h is 2,000 over x squared.
Wait, why is it 2x squared?
Because there's a top and a bottom. Okay? We have 250 each meter, so you take the area times 250. Okay? So this is going to become, when we simplify this down here, 5x squared plus 2x times 2,000 over x squared. And to simplify that all the way, you get c is 5x squared plus the x is going to cancel there, and you're going to get 4,000 over x. And then we derive that. Now in this simplified, we got it all down to one variable, so dc over dx is going to be 10x minus 4,000 over x squared. And to find out where that's going to be 0, common denominator, which is going to be x squared. So this is going to become x squared in the denominator and 10x cubed in the numerator. So this is going to be 10x cubed minus 4,000 over x squared. And that's undefined at 0, because that's the smallest x can be. And it's going to equal 0 when x is the cubed root of 4,000 over 10, which is 400. So to verify that this is a minimum for cost here, we need to make our number line here, where we're going to put our critical numbers on here, the cube root of 400. And we know that the smallest x can be a 0. And we know that if we plug in really tiny values close to 0 on this interval, the derivative, which is right here, is going to be a negative number divided by a positive, which is negative. And if we plug in really big numbers greater than the cube root of 400, we're going to get positive numbers divided by positive numbers in the derivative, and that's going to give us positive. So what that means is our cost equation is decreasing as x increases, and it decreases until x hits the cube root of 400, and then it starts to increase. So there's a minimum on the cost function when x is the cube root of 400. And the question said, let's find the dimensions, right? I believe, right? So, yep. We've got to go back up here and find h, and we know that h from this equation right here is just 2,000 divided by x squared. Well, that's going to be 400 to the 2/3, right? Because we had cube root of 400, which is to the 1/3 power, and we're squaring it. So simplifying this is going to be, again, a little bit of a pain in the butt, but we can do it here. We know that, let's see here. In terms of cubed roots, we know 8 goes into 400 50 times, so that's going to become 2 if you take that out. But we're also squaring it, so that's going to be 4 times, what do we take out? An 8, so it's a 50 times 50 to the 2/3. So h can be, the 4 goes into 2,000 500 times. And 50 squared, because it's to the 2/3 power there, is going to be really 2,500. And that's to the 1/3 power. There's really not a lot we can do with that. So I'm just going to leave it like that for right now. And our units are in meters. So the dimensions are, the height should be 500 over the cubed root of 2,000 meters. And the length and width should be, or the cubed root of 2,500, I'm sorry. And then the cubed root of 400 here. Meters. And again, with calculator, you can just write that out as a decimal. But that's fine for us at this point.